Hello everyone, welcome to Engineering Xplained channel. In this session, I am going to take Thermodynamics, first law of Thermodynamics, problem 4, which is a problem on steady flow energy equation, SFE. The problem or numerical is that the working fluid in a steady flow process flows at a rate of 220 kg per minute. The fluid rejects 100 kJ per second of heat passing through the system. The fluid enters at a velocity of 320 meter per second, pressure 6 bar, internal energy 2000 kJ per kg, specific volume 0.36 meter cube per kg, and leaves the system at a velocity of 140 meter per second, pressure 1.2 bar, internal energy 1400 kJ per kg, specific volume 1.3 meter cube per kg. Determine the power output in kilowatt. The change in potential energy is neglected. This is the flow system in which the inlet conditions at the inlet of the flow system conditions all given, that is a velocity, pressure, internal energy, specific volume at the inlet section are given and outlet section also are given. The mass flow rate of the fluid to the system is given and also the system rejecting 100 kJ per second of heat, and that is a heat output. We are going to take the heat output is a negative, and by taking this one we have to use the steady flow energy equation for the system. Then we need to find out the power out power output we need to find out in terms of the kilowatt. To find that one, we have to use the steady flow energy equation. First we'll take the what are the given data, that mass flow rate m equal to 220 kg per minute, that is we have to convert into kg per second by dividing with the 60. It will be 3.667 kg per second. Heat flow from the system, that is heat rejecting, is a Q122 is a minus 100 kilojoule per second or minus 100 into 10 raised to 3 joule per second. Negative sign is taken because of the heat output it is. Velocity at section 1 V1 is 320 meter per second. Pressure at section 1 6 bar, that is 6 into 10 raised to 5 Newton per meter square. Specific volume V1 is 0.36 meter cube per second at section 1, and internal energy U1 is 2000 kilojoule per kg at the inlet. Then V2 velocity at the outlet is 140 meter per second. V2 at outlet 1.2 bar, that is 1.2 into 10 raised to 5 Newton per meter square, and specific volume U2 is 1.3 meter cube per kg, and internal energy U2 is 1400 kilojoule per kg, and the change in potential energy Z1 minus Z2 or Z2 minus Z1, it will be equal to 0. Then what to find here? The work we need to find out. There is a power output, what is producing from this system we need to find out. Then further moving, we have the simplified steady flow energy equation, that is which will give the directly work, that is equal to the terms which are side of this work will be sent to the heat side. Therefore, the mass multiplied with change in internal energy, change in flow work, change in velocity, kinetic energy, and change in potential energy. All these we have taken plus of the heat transfer. Then, since here the change in potential energy is given 0, then simplify this equation, that is a W is equal to m into change in potential energy, change in flow work, change in kinetic energy plus of Q. So separately these are we can calculate and substitute in this equation, or we can substitute here only. Better to substitute calculated value after the calculating separately. U1 minus U2, that is the change in potential energy, 2000 minus of 1400 into 10 raised to 3 will take, because joule per kg will take. Okay, that is equal to 600 into 10 raised to 3 joule per kg. Then change in flow work, the P1 V1 minus P2 V2 will be, we'll substitute the pressure. P1 is 6 into 10 raised to 5 and V1 the specific volume is 0.36 and minus of The P2 is 1.2 bar, that is 1.2 into 10 raised to 5, and specific value is 1.3 meter cube per kg. And after the calculation, difference between these two, that will become say 60 into 10 raised to 3 joule per kg. Then the kinetic energy change, that is the mass we are going to multiply. Afterwards, here only we are going to take this velocity difference, that is a v1 square minus v2 square, that is a 340 square minus of 140 square by 2 will be the 40 into 10 raised to 3. And after substituting all these values, W is equal to the mass M is 3.667, and the first change in potential energy, change in uh, internal energy, that is 600 into 10 raised to 3 plus of the flow work difference 6 into 10 raised to 3. Then this is the kinetic energy, that is 40 into 10 raised to 3 minus of the heat, what it is there, it is a negative value we have taken. Then after calculation of this one, we are going to get the power in terms of the watt, kilowatt, that is a 2496.236 kilowatt. This is how the simplified equation we can use for the study to find out the power output. Then directly the equation we can use, and later we can simplify also, as we know the steady flow energy equation, and we can use the simplified equation also. Anything better to use the simplified equation for all these calculations, or initially if we have any confusion, okay, the steady flow energy equation will take, and that we can simplify to this form. That can be done. This is about this numerical, and further the different numericals I am going to solve in the further sections. Thanks for watching. If you like, share, subscribe and comment.